Good day, everyone. Welcome back to the channel. In this video, we'll be talking about Euclidean geometry and we'll be continuing with theorem number 2. So without wasting any further time, let's jump straight in. So with theorem number 2, let's say we're given a shape like this. What theorem number 2 basically says is that if we have an arc, obviously an arc in this case would be AB or a chord. If AB is a chord, if that arc or chord subtends the angle at a circumference, so it subtends this angle or supports in a sense this angle right here that you find at the circumference of the circle, that angle will be twice the size of the angle at the center, and the angle at the center obviously is this one right here, center O. Okay, so to put that in writing, let's say this is C. Okay, so what this theorem basically says is that ACB, right, will be, sorry, not even ACB actually, AOB, which is the angle at the center of the circle, will be equal to 2 times the angle, which is ACB, which is the angle at the circumference. The angle at the circumference. So in other words, angle at center will be equal to 2 times angle at circumference. Okay, I'm not going to finish writing that, but it's twice the angle at the circumference, and the reason for that is because they are subtended by the same arc or the same chord in this case. So if you have two angles, one is at the circumference, which is the one ACB, and you have another one which is AOB, and those two angles are subtended by the same arc or the same chord, the angle at the center, which is AOB, will be twice the size of the angle at the circumference. Okay, so this is not the only shape that they can give you, right? Another shape that they can give you, let me just quickly give you an example. Another shape that they can give you, let's say they give you obviously a circle in this case as well. Obviously it will be a circle since this is circle geometry, but let's say they give you a circle and you have your center here, and what you're told, obviously that will be A, and let's say we have C here and we have B somewhere else. I'm not going to put it for now. Let me just first draw what I want to draw. So let's say you have a line obviously that extends to that point, and you have another line that extends to that point, and then this line then goes and extends somewhere to that point, and then it closes off there. Okay, so now if you pay attention, you have your center here, and your center angle will be this angle. Your center angle will be this angle right here, right? And then your angle at the circumference will obviously be that one. So even in this case, the theorem still applies because as you can see, they're still subtended by the same arc, which is AC. They're still subtended by the same arc, or you can draw an imaginary chord, which is AB, right? So they're still subtended by the same arc, so that theorem still applies. It means that angle AOC will be equal to 2 times the angle at the circumference. Let's say this was B. Okay, so ABC. Okay, it will be 2 times the angle at the circumference, which is ABC. Okay, and the theorem basically says the angle at the center of a circle subtended by an arc or a chord is double the angle at the circumference subtended by the same arc or the same chord. And how you write the reason after declaring that or after the deduction, you say angle at center is equal to 2 times angle at circumference. So that's basically theorem number 2. Okay, it's also an easy theorem to kind of remember. I'll give you one more scenario in which this question can be asked, or how this can kind of be shaped. So now let's say we're given this shape, and here you have your A. Sorry, let me just remove that. Here you have your A, here you have your C, here you have your B, and obviously here you have your O, which is the center of the circle, right? So even in this type of situation, we would have this angle right here, which is the angle at the center of the circle, which is this one right here. Okay, so that's the angle at the center of the circle. If you pay attention, AB, in this case, it would be this arc, or this chord. Actually, let me say this arc. This whole arc right here. This very same arc subtends the angle at the center, which is O, and then it goes and still subtends the same the angle at the circumference, and in this case it would be ACB. Okay, so it would be ACB. So the angle at the center, which is O, will obviously be twice of ACB. So angle AOB, which is the angle at the center, would still be 2 times angle ACB. And as I've already mentioned, how you state your reason is you say angle, sorry, not angles, angle at center is equal to 2 times angle at circumference. So those are the 3 scenarios in which you can kind of see this theorem being asked. So don't now think that if only you're given this type of shape, that's when the theorem applies. In many cases, if you just see that this chord or this arc subtends the angle at a center, and then it subtends another angle at a circumference, you always have to deduce that the angle at the center will be twice the angle at the circumference. Okay, so just remember that it has to do with the center of the circle. That's the initial thing. So if you're told about the center of the circle, you're given a chord or an arc, then you can start looking for this theorem. But obviously, if you're not told that information, or you're not given that information, then this theorem won't apply. But in cases where you're told, then that's when this theorem can be applied, and this is how it's basically applied. Okay, so I wanted to make theorem 3 a new video, but I realized that it so relates to theorem number 2, or it's kind of actually the same thing to theorem number 2, so I'm just going to put it in the same video. Okay, so theorem number 2 says the line, if we have a chord that subtends an angle at the center, then that angle at the center will be twice the angle at the circumference, or the angle at the circumference will be twice the angle at the center, basically. Okay, so now with theorem number 3, it basically says if now we have a diameter AB and it subtends the angle, which is angle ACB, then angle ACB will be equal to 90 degrees. It will be a right angle. This triangle here will be a right angle triangle, or the angle ACB will obviously be 90 degrees. Okay, and if you kind of want to use theorem number 2's logic, is that AB is like it's a diameter, right? And if you pay attention to the angle at the center, which is obviously that angle that I just draw, it's 180, and we know that if the angle at the center is 180, then the angle at the circumference, if it's subtended by the very same chord or same diameter in this case, then it will be 90 degrees. Okay, so it's kind of like the same as theorem number 2, but the reason that we give in this case is that angles in a semicircle. So we say angle in a semicircle, or angles in a semicircle. In a semicircle. Okay, so we say angles in a semicircle, or we can just say diameter subtends right angle. subtends right angle. One of those reasons are valid. Okay, either one of those reasons are valid. So that's basically what theorem number 3 says. Okay, and the converse of it says, if then angle C is 90 degree, then we can assume that AB is like is the diameter. Okay, so if angle C is 90 degrees and we're told, then we can assume that the line that subtends it is a diameter. Okay, they don't have to tell us that it's a diameter, then we can just assume that it is a diameter. So yeah, that is it. So that's how I'm going to close this video. I will close it with theorem number 3 because, as I said, it's so similar, or it's kind of the same as theorem number 2 in that case, or in that like. But that is it from my side. Please don't forget to like, share, subscribe. I will see you in the next video. So the question here is, you are given that O is the center of the circle. You're also given that AOB, which is the angle at the center, is equals to 50 degrees. And you're told, or you're required to calculate angle X and angle Y. So angle X being this one and angle Y being that one. Okay, so now I need you to use the knowledge of your theorem 2 in order to find the value of X and Y. And I will require you to put down your answers in the comment section, and I will post my answer in a day or two. Okay, that is it from my side. I hope you enjoyed the video. Please share, like, and subscribe, and I will see you in the next video.